We often take for granted the simplest things in life. Like, have you ever looked at a glass of water and thought, wow, how does that even exist? Probably not. We learn about these basic concepts in school and assume we've got them all figured out. But what if I told you that some of the most fundamental things we encounter every single day, still have scientists scratching their heads? From the bizarre behavior of water to the very fabric of time and space, there are mysteries hidden in plain sight. These aren't obscure phenomena happening in some distant galaxy. We're talking about the stuff that makes up our world, our universe, even ourselves. So buckle up, fellow explorers of the cosmos, because we're about to dive into a cosmic conundrum, a head-scratching journey through 5 seemingly obvious things that science, as of yet, can't fully explain. Let's explore these things according to the synthesis from Cracked Through the article below. Let's start with something you probably can't live without: water. It's everywhere, it's essential for life, and it's weird. Seriously, water is straight up bizarre, and we still haven't figured out all of its quirks. Take its freezing point, for instance. Most liquids contract as they cool down, becoming denser in their solid state. Water? Nope. It decides to do its own thing and expands when it freezes, which is why ice floats. Now you might be thinking, so what? Ice floats, big deal. But this peculiar property is crucial for life on Earth. If ice sank, lakes and oceans would freeze from the bottom up, killing off aquatic life and making our planet a whole lot less hospitable. And why is ice slippery? You'd think something solid would be, well, not slippery. But nope, ice has this uncanny ability to turn into a low-friction surface, making ice skating and unfortunate slip and falls a reality. We know it has something to do with the way the water molecules interact at the surface, but the exact mechanisms are still debated. Think about that the next time you're enjoying a refreshing glass of water or slipping and sliding on an icy sidewalk. This seemingly simple substance holds profound mysteries that continue to baffle the brightest minds. Time. It's the one thing we all think we understand, right? It marches forward, never backward. Seconds ticking away at a steady pace. Well, not so fast. Time, as it turns out, is a slippery concept, a dimension that's far more complex than our everyday experience suggests. Einstein threw a cosmic curveball our way when he proposed his theory of relativity. Time, according to Einstein, isn't absolute but relative. It's affected by gravity and velocity, meaning time can actually speed up or slow down depending on your frame of reference. This isn't science fiction, it's a real phenomenon that's been experimentally verified. But here's the real head-scratcher. Why does time only move in one direction? This is the mystery of time's arrow. The laws of physics, for the most part, are time-symmetrical. They work the same way forward and backward, yet we experience time as a one-way street, always moving from the past to the present and into the future. Why can't we rewind time like rewinding a movie? Some physicists speculate it might have something to do with entropy, the tendency of systems to move towards disorder, but a definitive answer remains elusive. Time, it seems, is a river that only flows one way, and we're still trying to figure out why. Chapter 3. The silent intelligence of plants. Plants, those green leafy things that provide us with oxygen and look pretty in our homes, they seem pretty passive, right? Well, don't let their stillness fool you. Plants are masters of survival, capable of incredibly complex behaviors despite lacking brains or nervous systems. Take, for instance, their ability to solve mathematical equations. You read that right, plants can do math. Studies have shown that plants can calculate the optimal rate to consume their starch reserves overnight, ensuring they don't run out of energy before sunrise. This requires a sophisticated understanding of resource allocation and timekeeping, all without a single neuron firing. But wait, there's more. Plants are also expert communicators. They use a complex network of chemical signals, vibrations, and even scents to send messages to each other and to the world around them. That freshly cut grass smell we associate with summer, it's actually a distress signal released by the plant, a chemical cry for help. The question is, Why have plants evolved these sophisticated abilities if they can't move to escape danger or seek out resources? It suggests a level of intelligence and awareness that challenges our traditional understanding of consciousness. Plants might be stationary, but their silent world is teeming with activity and complexity we're only beginning to unravel. Chapter 4: Pi's Infinite Secrets. Now let's delve into the realm of mathematics, where we encounter a number that's both familiar and infinitely mysterious. Pi. We all know it as the ratio of a circle's circumference to its diameter, approximately 3.14159 and so on. But that and so on is where things get really interesting. Pi is an irrational number, meaning its decimal representation goes on forever without repeating. This seemingly simple fact has profound implications, making it impossible to ever calculate the exact circumference or area of a circle, no matter how powerful our computers become. But Pi's infinite nature hints at something even more profound. Some mathematicians believe that within Pi's endless string of digits lies the answer to every question, the code for everything in the universe. It's a mind-boggling concept, like a cosmic library containing infinite knowledge, if only we knew how to read it. The problem is, Pi's infinite and non-repeating nature makes it incredibly difficult to analyze for patterns or meaning. It's like trying to find a specific grain of sand on an endless beach. We've calculated Pi to trillions of digits, yet its secrets remain elusive. Pi stands as a tantalizing reminder of the vastness of the unknown, a numerical enigma that continues to fascinate and frustrate mathematicians. Chapter 5: The Hidden Dimensions of Reality. We experience the world in 3 dimensions: length, width, and height. It's how we navigate our surroundings, how we perceive the universe. But what if I told you that our 3-dimensional world might be just a tiny slice of a much grander, multi-dimensional reality? String theory, a leading contender for a unified theory of everything, suggests that the universe might have as many as 11 dimensions. These extra dimensions, curled up and hidden from our perception, could hold the key to understanding some of the most fundamental forces and particles in the cosmos. The 4th dimension is often considered to be time, but what about the other 7? They exist beyond our ability to visualize, but their influence could be felt in subtle ways. Phenomena like quantum entanglement, where particles appear to communicate instantaneously over vast distances, hint at connections that transcend our 3-dimensional reality. Imagine a universe where gravity leaks into other dimensions, explaining its weakness compared to other fundamental forces. Or a universe where parallel universes, separated by dimensional barriers, might exist just a hair's breadth away. These are the mind-bending possibilities that arise when we consider the existence of hidden dimensions, a cosmic puzzle that physicists are only beginning to piece together. Outro, the universe of unknowns. So, there you have it. 5 seemingly obvious things that science still can't fully explain. From the enigmatic nature of water to the hidden dimensions of reality, the universe is full of mysteries that continue to challenge our understanding. But these unanswered questions aren't a sign of defeat. They're an invitation to explore, to push the boundaries of knowledge and delve deeper into the unknown. It's the very existence of these mysteries that drives scientific progress, fueling our curiosity and inspiring us to seek answers to the most fundamental questions about our universe and ourselves. Stay curious, my friends, and never stop questioning the world around you. After all, it's the things we don't know that make the universe such a fascinating and endlessly intriguing place to explore.